So the arithmetic we're going to have to work with is going to involve proportions, and it's going to involve radicals. So when we work with geometric means, we are usually going to have to deal with a radical, and they should always be written in simplest form. Writing them in simplest form means that no perfect square factor other than 1 is under the radical sign. So in essence, we're going to be talking about breaking down our radicals. We also can't have any fraction underneath the radical sign. And no fraction has a radical in its denominator. So these are the 3 things that are really, really important. So make sure that you're writing this down, because in simplest form, radicals written in simplest form means these 3 items right here. 1, 2, and 3. 1, 2, and 3. So let's get started. First example, we're going to have 5 times the square root of 18. So 5 times the square root of 18, there is a perfect square underneath that radical. And the reason I know that is by, of course, experience. However, I'm going to rewrite the square root of 18 into a product of its prime numbers. So the product of its prime numbers are going to be 2 times 3 times 3. And the perfect square that's underneath that radical is 9. Now, how did I know this so quickly? Well, I've broken down 18 enough times that I'm able to break it down in my head, but this is how I break down radicals. I use prime numbers. 2 is our first prime number. If 2 goes into the number, I'm going to check to see if 2 goes into that number again. 2 does not go into 9, therefore I'm going to use the next prime number, and the next prime number is 3. And 3 does go into 9 3 times. This ends on a prime number. So when it ends on a prime number, we are done. We are done prime factoring. We are done prime factoring. So 2 times 3 times 3, 2 times 3 times 3 is another way to write 18. And now I have a pair of 3's, which is the square root of 9. The square root of 9 is 3. Well, I had a 5 out there. So I've got 5. Now I have times 3, because the square root of 9 is 3. And then what's left over is that 2. So our answer is 15 times the square root of 2. And that is the same thing as 5 times the square root of 18, but this is simplified. So this radical on the left is simplified. Let's try again. The square root of 3 over 2. Well, if we look at our steps in the previous explanation of simplest form radicals, no fraction is underneath the radical sign. So we've already done an example of number 1. So now we are on number 2. The square root of 3 over 2. Well, that's a fraction underneath the radical. So I'm going to rewrite this as the square root of 3 over the square root of 2. And I'm going to multiply the denominator by the square root of 2 and the numerator by the square root of 2. The square root of 3 times the square root of 2 is the same thing as the square root of 3 times the square root of 2 under the same radical. And then the square root of 2 times the square root of 2, same thing. But the square root of 2 times the square root of 2 is the square root of 4, which is just 2. And then we have a square root of 6 in the numerator. Well, that's not a perfect square. So the square root of 3 over 2 is equal to the square root of 6 over 2. The square root of 3 halves, that's probably how I should have said that. The square root of 3 halves is equal to the square root of 6 over 2, where 2 is not in the radical. Clearly, it is not in the radical. So you need to make that very clear in your answer. So let's do another example here. The square root of 10 over what do we want to do? Let's do 10 over 7. So the square root, here's another example. The square root of 10 over 7 is the same thing as the square root of 10 over the square root of 7. I'm going to multiply the denominator by the square root of 7, which means I have to multiply the numerator by the square root of 7, so that I'm multiplying by a factor of 1. Now the reason I do this is so that I don't have a radical in the denominator. So I end up with just a 7 in the denominator, no radical, and in the numerator I've got the square root of 70. The square root of 70 is the same thing as 7 times 10, which is 7 times 2 times 5, and there are no perfect squares, so I can keep that as the square root of 70, just like that. So that's an example of simplifying radicals. Okay, we've got one more for you, and I think I'm going to let you try this one. So here's one for a try. And then when you're ready to check your answer, go ahead and press play. So the answer to this is 3 times the square root of 5. 3 times the square root of 5. And we get that by taking the fraction and multiplying by the square root of 5 over the square root of 5, which gives us 15 times the square root of 5 over 5. But then in the numerator, I've got 3 times 5 times the square root of 5 all over 5. These 5's cancel out, which gives us 3 times the square root of 5, which is our answer. Now in the next example, we're going to include some triangles. So in the next example, we'll include some triangles and work with